Well, hello. Today I'm going to talk to you about smart matching enabled by the ROR API that we use for publisher integration with the OA Switchboard. But before I do that, let's do a quick introduction. My name is Ivo Verbeek. I'm Director of Appetence BV. We're based in Amsterdam, Netherlands, and we are a solution provider in publishing. My background is in IT. I've developed software for 20 plus years. And since 2002, 2003, we're also working for a variation of clients in academic publishing. Relevant for today is that Appetence helps publishers to integrate with the OA Switchboard. Also relevant to mention is that we have a dedicated team of developers at Elitex Development Center in Ukraine. And Elitex is also the tech partner for OA Switchboard. So what's the OA Switchboard? It's essentially a message hub. That's the core of what it is. It's a central information exchange hub used by different parties like research funders, libraries, institutions, consortia, and publishers to exchange OA-related publication level information. But as I said, the core is a message hub. It allows stakeholder 1 to send a message to the hub, and the hub relays it to stakeholder 2, and then back. That's the core of what we do with the OA Switchboard. Then, of course, there's standard messaging protocol, there's automated validation, there's routing rules. And this is a shared infrastructure connecting and complementing existing systems and solutions. It's highly integratable with various systems, and that's what we do. And that's also why we mention it today. Also relevant is that it leverages persistent identifiers, including ORCID, also including ROR ID for institutions. So where does Appetence come in? Well, it's that arrow where the publisher sends a message to the message hub. The message hub has an API, but there might be all kinds of reasons why the publisher can't directly integrate with the API. And that's where we help these publishers with the integration. We build so-called custom connectors with or without a private data store. And that allows publishers to send messages through the switchboard to institutions and research funders. So what does that look like? A custom connector with or without a private data store. In practice, there's a variation of systems in the back office of a publisher, including editorial systems, publication level, VOR, information content distribution. There's deal information, there's publication level financial information in place for OA, of course, journal master data. So that information is not always in one place. So we collect it, we receive the data in the custom connector. And if the data comes in asynchronous, then we also need to store it in the private data store in order that we can actually combine it. Then we generate the events, we apply business rules, and ultimately we compose and send messages. And this is especially important if the information that's needed in a single message comes from various sources, like VOR information that might come from a content distribution system and publication level financial information, the APC charges basically coming from financial systems. Ultimately, this custom connector connects to the switchboard on the standard API in the standard message structure. So here's an example. For most publishers, unfortunately, affiliation information is nothing more than a text field. So the publisher system might contain a text field saying affiliation Vrije Universiteit Amsterdam, which is the local Amsterdam University here. That information is made available to the custom connector through Jets XML. That's exactly the same data feed that the publisher might also send to Crossref, for example. So that Jets XML comes into the custom connector, and at that point, the smart matching comes in. So what we actually do, we take the text field, we request the ROR API on the affiliation matching endpoint, which you will see examples in the next slides. And then it returns to us a ROR ID. So we enrich the data with that ROR ID, and then ultimately when the JSON message is sent to the Switchboard API, it contains the ROR ID for the VU Amsterdam. It's also possible that if this doesn't work automatically, we use a mechanism with a score, and if it's below a threshold score, then simply we don't know for sure. Then we also have an optional human check through the Mechanical Turk mechanism, which is bottom line very basic tasks that you can outsource. So that's also an option for the custom connector and private data store. So here is the API endpoint that we trigger. It's the API ROR organizations, and this is the affiliation matching endpoint. And we just put in the Vrije Universiteit Amsterdam text field. Then it returns to us 16 results. The first result, as you can see, the chosen is true. So it's the chosen one. It has a score of 1, so a perfect score. And it returns to us the ROR ID for VU Amsterdam. So this is a perfect example how this works. The ROR ID we use to enrich the message that's sent to the OA Switchboard. Here is a second example, which is not so perfect. In this case, the text field that we see in the publisher data field contains Department of Medical Sciences, Clinical Chemistry, University Hospital. Well, probably not even a human knows which institution this is, but the ROR API returns 64 results, but it returns a result on just University Hospital. And that's most likely because there's a comma behind clinical chemistry, and then a comma, and then University Hospital. So it finds plenty of matches on University Hospital, and in this case, University Hospital Erlangen is put as the chosen one with a score of 1, which is clearly a false positive. Yeah, it's not supposed to go to Erlangen, but unfortunately, that's what we get. So we need a mechanism in the smart matching to identify that. So what's the results of this? Well, we have now done over 100,000 requests, and over 50% returns us matches with a score threshold at 0.9. So actually that's pretty good. We get a lot of matches, and the quality of the matches is also good. It's an estimate, but we estimate that over 99% of the matches are actually the correct institutions returned to us. So that's great. So, but unfortunately, we also have to deal with the exceptions. I gave the exception of Erlangen. So at this time, we deal with that through a stop list. Unfortunately, again, that's dependent on feedback. So we are dependent on Erlangen telling us that they're getting messages that they're not supposed to get. And then we can add it to the stop list. Is that ideal? No, of course not. So we're still looking at other workarounds in the ROR affiliation matching. We've raised an issue. It's there in the community forum. So we hope that in the near future we can improve this mechanism to also catch those exceptions. Of course, then there's the alternative, which is the human check. So we could implement this Mechanical Turk mechanism in the publisher workflow, as I've demonstrated in a previous slide. But Yeah, to put this in some perspective, the ultimate scenario is, of course, full support for persistent IDs throughout the publishing workflow. Why does the publisher have just a text field at that point? Well, there are few publishers who actually do have full support for these persistent identifiers throughout the publisher workflow, but unfortunately, the majority doesn't have that. So for those, we offer smart matching as an intermediate solution. But the ultimate goal is, of course, that we don't need it anymore. That's it. Thanks for your attention. And if you want to reach out to me or my colleague Yuri, feel free. Thanks.